Hello, everybody, and thank you for joining our November 9th Lunch and Learn on the ER path. It is brought to you today by our sponsors, Rocky Mountain Power, Dominion Energy, and the OED, our Office of Energy Development. We will be listening to Troy Pressler today speak about the ER path and go from there. So thank you, everybody. Here's Troy.
Good morning, everyone. As mentioned, my name is Troy Pressler, and I am with Building Science West. We're a local HERS rating company. A little bit about me. I've been in the energy efficiency business for about 15, 16 years, working on programs for Rocky Mountain Power, for Dominion Energy, and several other utilities across the country, really helping to manage their utility rebate programs for new construction. So that's a bit about me. Used to do lots of quality assurance inspections for the programs. A lot of the programs required Energy Star as a prerequisite for the incentives and rebates. So we did lots of verification of Energy Star qualified homes. So it's a little bit about me. So what we're going to talk about today is the ERI path to compliance. But I want to just talk a little bit about building codes in general, and then we'll start from there. And I apologize, I'll probably take my glasses on and off about 100 times in the next little bit because up close, far away. If you're not there, you'll get there someday, and enjoy. All right, so I guess quickly, and I apologize for those online, I'd like to just get a quick assessment of who we have in the audience, and what you do and why you're here. Just help me understand kind of where people are coming from. And can we start over on this side of the room?
I'm Aaron Hospick, broker and developer, and also financing.
Okay, broker, developer, and financing. Let's just move across if we can.
Short and North, residential building plans examiner,
Okay, with whom?
WC3.
Oh, okay, perfect.
Same, Greg Kniff, WC3, works previously with Safebuild, familiar with them as well. Residential building inspector, plan review.
Okay, so we have a couple of, I'm sorry that I'm going to just repeat stuff that y'all say so that those online know what's going on. So a couple of plans examiners, building inspectors, HERS rater.
First rater, building inspector.
Yeah.
Party, GC3.
GC3, okay, and then,
I'm Mike, 24 Construction, residential home builder.
okay, a residential home builder, fantastic. And if it's okay, when I ask questions, can we not consider them rhetorical and just blurt out an answer if you've got it? It makes it, I think, a lot more interesting for everyone if we can have some back and forth. And again, if it's a short thing, I'll just repeat it for those online. If it's a little longer on your side, we'll just get a microphone to you and go from there. So when I ask, why have building codes? What? And I've taught a million of these classes for the Home Builders Association, and usually the answer I get at those classes is to make my life a living hell, is usually the answer I would get. But of course, mostly a joke. But tell me, why have building codes?
So we don't end up like three little pigs.
So we do not end up like the three little pigs. Yeah. So their homes were not rated for huffing and puffing and those sorts of things. So just a couple of silly photos. I hesitate to think that this would have happened on a new build, but obviously you've got a couple of trades that are not communicating with each other. I probably would have just shortened the blades on the fan myself, but whatever works for you. This is an example, I think, of why it's good to have, I'll say, a disinterested person reviewing everyone's work and making sure that everything is where it should be. And by disinterested, someone who's not getting paid to complete the work, and someone who has, some overall responsibility for the project. No, we don't have any HVAC contractors here. Anyone point out what might be wrong with these photos? Got some chuckling here. So what we have here is a ductless mini split install, and what we've done is we've installed the indoor unit outside and the outdoor unit inside. So, yeah, cooling the
Global warming.
yes, helping global warming, but not helping apartment warming, right? Yeah. So no matter how much you crank on the thermostat, you're just not going to get comfortable in that situation. Again, I doubt that was new construction, but it just is good for a chuckle, and I think maybe illustrates why it's good to have oversight from trained people. Okay, so I will confess to everyone here that I majored in history in college, and so why have building codes? Really, the origin is occupant safety, right? Three Little Pigs, they got their homes blown down. I think, unfortunately, the recent tragedy, I guess over a year ago now, though, the condominium in Florida that collapsed, that's obviously a worst case scenario for why we want to have building codes. So, first code items in actually it wasn't the United States then, it would have been the colonies, actually date all the way back to the 1600s in what would have been, I guess, just the colony of Massachusetts, is when they started happening. I was surprised that they started that long ago when I started digging into this. Any guesses on any of the first building code items that we would have addressed in Massachusetts in the 1600s? Roof? Oh, you win. Roof was one of them, yes. One of two that I've got here. Let's stop making chimneys out of wood. Was one of them, one of the very first ones. And then let's stop using thatch for our roofs, really for the same reason. We don't want our homes burning down. And really, fires and tragic fires, unfortunately, were some of the early drivers of building codes in this country. Even though building codes in general actually date back to 2000 BC. Back in those days, if your building collapsed and killed anyone, it was expected that you would die as well. So things have become less rigid. Okay, so if building codes in general are for occupant safety, why have energy codes? They don't have anything to do with occupant safety. What's the first thing that comes to mind when you say why we should have energy codes? Occupancy comfort. I think that's a great answer. In fact, I usually don't get that answer, but it's my favorite one. Anyone else? Say again?
Financially, you're better.
Yeah, financials.
Healthy.
Okay.
Environmental reasons.
Environmental reasons. Yeah. Well, so here's a problem. This is just a ventilation fan. Now, you might say, what's the code item that this is violating? You looked at the ceiling.
I just reviewed some plans today and yesterday, and one of the items we had is what's the CFM rating on it and how many bends
Yeah, yeah. So, what's the CFM? So, the code items that would apply. What's the CFM rating of the fan, and how many bends are in the duct? And certainly, if that fan is rated for 80 CFM, and I didn't test the fan, but I'd spitball the actual output of that fan at probably 20 to 30, something like that. My suspicion is that fans are required to be installed per manufacturer's recommended installation instructions, and that is a massive violation of those. Every fan I've seen requires 18 inches of straight duct before there are any bends in the duct, really to allow the probably the turbulence of the air from the squirrel cage to settle down before you go through any turns. So this fan will not move much air, and why do we care about that? Well, we're not going to be removing the water from the bathroom as we're supposed to. This one, I don't know how well it shows up for y'all. This is just a standard, butterfly joint on a rigid duct. It looks like there is a little bit of pookie on it, but it's just underneath the round duct, and so this will be a massively leaky joint. And if there are many of those, I am confident that duct system and that HVAC system won't function as it's designed, and you can actually run into a lot of items with this, not the least of which are comfort issues. But having leaky ducts and or leaky returns, because the supply side is positive pressure, the return side is negative pressure, and if you have leaks in those, you can put rooms in the home under positive or negative pressure, and that can create driving forces that can push moisture into walls. And in cold climates, moisture in walls is a bad thing. Condenses, and then bad things happen. So there are plenty of reasons why that doesn't and shouldn't meet code. I don't know that there's a code item about that, but it's just so egregious I had to put it in. You would think that is supporting a 6-story building or something. That's just a 2-story townhome. And I walked that with the developer, and when he saw that wall, he just face palmed, grumbled about how his framers must think that wood is free, and people are probably going to wonder why the light switch is 2 feet away from the door, and and also why there is a almost 2-foot wide section of wall. This is a 2x4 wall that is roughly R3.5 instead of, I don't remember if those bats were R11 or R13, but roughly 1/3 the R value of the rest of the wall. So again, these are the things that add up and make big differences in the performance of homes. So energy codes, comfort, operation costs, water management, and home durability. I feel like those two really do go together, and we touched on it a little bit. The energy code that I feel like applies to this is there are air sealing portions of the energy code, and again, keeping the warmer, more humid air out of the walls in your house is really what's going to help with durability. So, Utah Energy Code. We are currently in year 7 of a 6-year code cycle, and we are on IECC 2015 with Utah amendments. We will be moving to IECC 2021 next year. I believe implementation should be July 1st. there will be, I'm sure, negotiations within the legislature about what, if any, amendments will happen to that code. That remains to be seen. Again, the legislative session will start up late January, go to March, and we'll know at that time the specifics of the code we'll get. But that's where we're at now. That's where we've been. Again, we're over 6 years now on our current code. Okay, so energy code compliance. There are 5 ways to comply with the energy code for getting your permit. One of them is you can just do a prescriptive. There are prescriptive tables for where your windows and walls and attic need to be, and you can just follow that prescriptive list, turn that in, show documentation for it, and obtain a permit. How do you go about, what do you use for your code compliance for energy code for pulling permits? What?
Well, we have to, like for heating and air, the heating contractor has to prepare their documents that we turn in to the building department.
Sure. Yeah, so they turn in their manual JD and S documentation. Yeah, okay.
Other than that, I mean, I opt to try, I like to get 24 in my walls,
Okay.
50 in the attic with a raised heel truss, so that I can get my insulation right over the top. I have the sheetrock or caulk around the ceiling when they put the lid on it,
Yeah.
and also the base plates. So we do, we try to do things like that to make the envelope.
Yeah, so you've gone well above the code requirement with R24 walls, R50 attic, raised heel trusses, air sealing.
There's a balance for windows. I mean, cost-wise anyhow, you try to get the U value as low as you can.
Yeah, and windows I feel like are pretty good. Most windows you buy today are pretty good, the standard ones. So 5 paths. I kind of broke it into 3 categories of paths. Again, I started with the prescriptive, which is you list out specifically the things that you're going to do, and as long as and there's the list of code minimums. As long as you're above in all of those categories, then they'll give you a permit. There are 2 compliance paths that use ResCheck, which is either an online or free software that you can get. And one of them is the UA Trade-Off, which uses a 2015 version of ResCheck. Here in Utah, we also have the percent above the 2012 Utah code. Again, it's using ResCheck, and right now we're at, because 2012 code was a while ago, what we did is, we being the state of Utah, if you're 5% above, your ResCheck shows 5% more efficient than the 2012, then that gets you passing for code. Then there are 2 more paths to compliance. One's called simulated performance, and the other one is the energy rating index, which is really what we're here to talk about. Both the simulated performance and the energy rating index use an energy modeling software to determine code compliance. And the simulated performance, you just need to create an energy model that shows that the home performs as well as that home built to code minimum, as well as or better than. The energy rating index, what that one is, an ERI, so I apologize, I very well could use ERI and HERS interchangeably. The difference between those 2 is the difference between a Band-Aid and a bandage, and a Kleenex and a tissue. HERS score is basically a brand name of ERI from ResNet, and I'll talk more about what ResNet is. So if I slip into using those interchangeably, know that one is really just a copyrighted name, and a HERS score is one example of the category of energy rating index scores. So there could be others from other organizations. So a third-party rater, which is what Building Science West does and others do. There is also a list of HERS raters in the state of Utah at utahenergycode.com, which is where all this information is found, and is a wonderful resource for Utah Energy Code information. There's a list of HERS raters, and if you guys aren't up there,
Yeah, we're pretty new.
you'll want to talk to Jacqueline, I think, probably about getting on that list. So, we generate an energy rating index score for the house, and then that can be used to obtain your building permit. And, so I guess I've already kind of hit this. The 1 prescriptive, 2 res checks, 2 REM rates. Okay. So simulated performance, we already hit that typically, and they're done by energy rating specialists, which again, there's a list of them on the Utah Energy Code website. And I don't know that there are any, I think all of them in the state of Utah are HERS raters. Or at least there's a good sampling of HERS raters that can perform that work for you. Do y'all use REM rate, or do you use something else?
We use Ecotrope.
Ecotrope, okay. There are a variety of softwares that HERS raters use. Most of the raters I know use REM rate, but there are other versions as well, and the different versions have pros and cons. But certainly Ecotrope will work for generating these as well as REM rate. Okay, res check versus REM rate. I have somewhat irreverently joked that using res check to determine the energy efficiency of a home is like unto using a machete for brain surgery. It's just not very accurate. It doesn't really have the detail that you need to dial in. But it doesn't need to be. They're different in purpose. Res check is really just to get your permit. I don't think it was ever designed for analysis or anything deeper. And really the only reason to use res check is for gaining a permit. Definitely different in level of detail. So let's get into REM rate a little bit. And again, I would assume, I haven't used Ecotrope, but I'd be surprised if there was much difference in kind of the meat and potatoes of the two different softwares. So there are a lot of data outputs that are available from the modeling softwares. One of them is the energy cost to operate the home. It's just in REM rate, it's just called the fuel summary report, and it breaks down how much it's going to cost in electricity and gas, and it breaks those costs out by different categories, whether it's your mechanicals, appliances, lighting, plug loads, things like that are all broken out. That's one of the things that you can use. And the HERS score, it's designed, it was always designed to be a single number that you could use to represent the relative efficiency of a home. The people that designed it really came from the EPA. They always use the analogy that it's miles per gallon for a house, which is pretty good. It works pretty well for that. I know some people don't like that analogy, but it's a good place to start. More of the outputs that you can get with the software are, does that home comply with various versions of code? And it'll also tell you, based on the inputs, whether the home meets Energy Star requirements, and other above code certifications as well. So what is a HERS score? I told you that it's used to describe a home. HERS 100, this is where a lot of people get it wrong, actually. And HERS 100 is a home that was built to code minimum based on 2006 code. I will say some builders who focus on energy efficiency and advertise their HERS scores will erroneously say that the average home in Utah is a HERS 100 and theirs are much lower than that. It's not true. The average home in Utah is not HERS 100 because our code is well beyond the 2006. I don't know what the builders we work with are probably better than average because they're working with a HERS rater. And I would guess 60s, 70s would be the HERS scores we probably see a lot of for just the kind of up at the upper end. Certainly some go lower. A HERS 0 is a home that generates as much energy as it uses. That's really a net zero home. So, of course, all the homes fall somewhere in between that. Not mine. My home's 140 years old. It is above 100. So, what's the saying? The cobbler's children go barefoot or something like that? Yeah, that's me. HERS points also get a lot more difficult the lower you get down on the scale. We did some analysis for a builder not too long ago, and they said, what do we need to do to get all of our home plans at HERS 50 or lower? And some of them we were able to get down pretty easily, but some of them they had to be spec'd quite heroically, quite honestly, to get to HERS 50, and with ridiculous amounts of wall and attic insulation in them. They're already using good equipment. And then I saw on an email, they're like, 50, 52, 53, whatever. And I had to stop. I'm like, no, there's a huge difference between a HERS 50 home and a HERS 53 home. Now, I would say there's not a huge difference between a HERS 69 and a HERS 72. Those are pretty similar, but again, the lower you get, far more intense to lower those. And in fact, at a certain point, it really just becomes not only easier but more cost-effective to stop with the efficiency and just throw renewables on the house. It's just cost less money. Once you've reached a certain level of insulation and air sealing, adding more just doesn't do much to it. If you've already got R60 in the attic, going to R70 doesn't help that much. So at a certain point, you just put renewables on. And there is a program from the Department of Energy called Zero Energy Ready. Are you guys working on any of those homes? That is really designed. It's Energy Star is one of its requirements, but it goes beyond Energy Star in efficiency and some other details. And it's really designed to get your home to that trade-off point where to go any more efficient than that, it's really just more cost-effective to add solar panels to your home rather than upgrading equipment, lighting systems, anything like that. Again, just at a certain point, it becomes really expensive. So, okay, so what is a HERS rater? HERS raters have to go through rigorous training and testing. It's a lot harder now than it used to be too, especially with all the CAS testing. Yeah. So in building science. So what is building science? Building science is really just how the physics principles of airflow, heat flow, moisture flow, how those apply to buildings. It might sound simple, it's anything but. It's really complicated. That's one of the things that HERS raters are trained in. Blower door testing, we'll talk a little bit more about that later on, but that tests the how leaky a building is under specific circumstances. Duct leakage testing, same thing, except for instead of the whole unit, we're really just looking at the duct system. Airflow testing, that's going to be testing how well the ventilation system works in a home. So typically, what most people think of would be a bath fan, how well those are functioning, specifically in relation to how they should be functioning based on the specifications of the fan. Energy modeling, that really refers to taking the information from the home or the building and getting that information into software, and it's really can be quite rigorous and detailed. So we're looking at the square footage of every wall in the home, the square footage of every window, the efficiency of the walls and windows, all the information so that that software program is able to understand all the relevant details of the home so that the analysis can happen. So HERS raters are regulated by an organization called ResNet. And so we do inspections on homes, and we do software analysis on homes. And then there are organization called HERS providers, and are you your own HERS provider?
We use the bear.
Okay, yeah. So HERS providers, they look at the work that we do, and they double check our inspections and review our paperwork and analysis and make sure that it is up to industry standard. And ResNet, as an organization, it works in conjunction with the EPA. So the EPA had to authorize ResNet as an organization to be able to certify homes as Energy Star, because Energy Star is an EPA program, and so they have authorized ResNet to do that. And then again, ResNet goes to the providers and providers to us. So it is a heavily regulated industry that we're in, but it really works to ensure the integrity of the work that's being done, and that sound standards and principles are being used for the inspections and the modeling and everything that's going on. So, and there are continuing, just like a contractor's license, continuing ed hours have to happen as well to maintain your HERS certification. So, why choose the ERI path for compliance? I'll call this a non-rhetorical question. Why would you want to do that? Nobody knows. Okay. I will confess that we do not very many ERI path homes for code compliance. We do a lot more res checks for builders than we do ERI path code compliance. So why would you want to do it? We do some. So here are the reasons that I think you would want to do it. And the builders for whom we do it, they are builders that are very serious about their energy efficiency, about their certifications that they get, and they have corporate policies. I think all of them are national builders, actually, that we do it for. And as a corporation, as a builder, they've just decided that their homes are going to be at a certain standard with efficiency and with certifications. So, one reason to do it is you can, depending on where you want to end up, you can double dip. You can create the energy model for your home in Ecotrope or REMrate and generate your ERI and show that you have code compliance. And so you've done that work for the home. Now, some of it, when you're pulling your permit, some of the information has to just be assumptions. Just we're not going to obviously know what the duct leakage and infiltration rates are for that home before it's built. So you just put in some reasonable assumptions to get your permit. But then that energy model, that REMrate or Ecotrope file is going to be in existence already. And so if you want at the end of your building cycle to do some other things, part of the work is already done. Where with a res check, you do that work, get your permit, and then that work is not used anymore. So having an energy model at the beginning gives you the opportunity to take a look at your home and see where it sits as designed and as spec'd out, and see if it's where you want it to be with regards to what the energy the operational costs would be with regards to utilities. And once that model is built, which does take a decent amount of time, but once that model is built, it's relatively easy to go in and tweak different things on it and just say, well, it's costing more to heat this home than I really want it to, or my HERS score is higher than I want it to be. What happens if I bump up the efficiency of my cooling system? Let's go with a 15 SEER air conditioner instead of a 13 SEER. How's that going to affect things? And so you can just go into that page on the in the software and make that change pretty easily, and then just rerun your outputs, and it's going to tell you that's going to drop your HERS score by 1 point, and it's going to drop your annual utility bills by $26 or whatever, and it's going to cost you $400 to upgrade the air conditioner. And I'm making all these numbers up, and so it's going to take 10 years of usage to pay for that air conditioner upgrade. Is that a decision you want to make? Who knows if it is, but at least with the software, now you've got all the data you need from a financial standpoint anyway to decide what is the most cost-effective way to upgrade the efficiency of the home, whether it is mechanical systems, appliances, insulation, whether it be below-grade walls or attic, other things. So it really gives you a good picture of how that home is going to perform, and so that you can make informed decisions on where you want to go. Also, it lets you know, gives you a snapshot anyway. There are certainly some things that have to be determined throughout construction, but if you decided that Energy Star is something you want to go after for a home, and I'll just touch on at some point during the day why that is becoming a far more attractive option than it was in the past. But whether it's Energy Star, up in Silver Creek up by Highway 40, you have to be NGBS green to build in there. And so this would tell you if you're how you're doing with that. Certainly if you're in Daybreak, you need to be Energy Star. And there are other certifications that build off of the information that you would get from an energy model that's created when you find an ERI. So what goes into a HERS score? So probably the first thing you'd think of is the R values from I just put in their exterior surfaces of the home. And that would include anything below grade, whether you're doing insulation on the inside of a basement wall, or if you've got slab on grade and you're doing rigid foam on the outside of the slab or inside the stem wall. So there's different categories of insulation, and typically it's just the three. Isn't it? Foundation, walls, and attic are really the three categories of our values that you look at. It also looks at gives you an opportunity to make a judgment call on how well the insulation was installed. And it's actually it's really just grade 1, 2, or 3. But if the insulation is poorly installed, you're able to reflect that in the model, and it will downgrade basically the efficacy of the insulation. And that's pretty important because, in fact, Energy Star requires a grade 1 install. So you could put in double the required insulation, but if it's poorly installed, you're still not going to meet Energy Star requirements. And here's the reason for that. So the way insulation works is by trapping and holding air is really the way insulation works. If you've got foam, there's a million little bubbles in there that are full of probably atmosphere, I suppose. And basically it's holding that air and not letting it move, not letting it go anywhere. Fiberglass works the same way. All the different insulation types do. That's why typically by volume insulation weighs very little, is because by design it's supposed to be mostly air. So if you have a stud cavity and it's got a bat, and I had this discussion with a builder either this week or last week as we were looking at his insulation install, and that the insulation specifically on the sides was pushed way back in. These were 2x6 walls, and on both sides and top and bottom they were all squished in to about half of the depth of the stud cavity. Anyone want to tell me why that's a really bad thing?
Create a conductive air loop in the walls.
It creates conductive air loops in the walls. So if insulation, its basic, the methodology for its basic function is to grab air and hold on to it and not let it move. But once that sheetrock is up, there are 2-inch gaps between the insulation and the sheetrock on both sides, top and bottom, and hot air rises, cooler air follows. What you've done is you've just set up a wonderful path for conductive loops to function in that stud cavity. And the industry term for what's going on there is that that stud cavity is short-circuited as far as insulation goes. So once you've got the air rising and falling, you actually create the minuscule pressure differences, and once you've got pressures driving, then you're moving air not just within that stud cavity, which is bad enough, but greater drivers to move air in and out of that stud cavity. So for insulation to function, it needs to be in contact with the surface that it's insulating, and it needs to stop air from moving. So the software allows us to make a judgment call on that, the install. And again, most certification programs require a grade 1 install. Speaking with a builder a week or so ago who is building Energy Star, he said, my insulation contractor said he won't install bats on Energy Star projects. It's just too much of a pain. He will only do blown in, and it's going to cost me more. And I said, I'm sorry that it's going to cost you more. He is 100% correct. it is really a big pain to get bats installed correctly. In fact, do you ever see it?
Never.
Never, yeah. Sometimes I feel jaded when I say, no, I've never seen a bat like installed correctly. Maybe a single bat, but not an entire home or an entire unit. If every stud cavity was perfectly empty, you'd have a fighting chance. But if you step back and look at a home, most of them have something going on in them, even if it's just Romex heading through it, or a switch box or an outlet, or something else going on. And that's where it takes a lot of work to get the bat installed correctly. Most insulation contractors, the bat installers, the insulation installers, are paid by the piece and not by the hour. So they're incented to get it in there as fast as they can and move on to the next stud cavity. So it just doesn't happen. So typically blown-in insulation is really the only stuff that gets a grade 1 install. All window information. So windows on homes, they all have to come with what's called an NFRC, National Fenestration Rating Council, I believe. And they are the ones who certify windows. And so there will be a couple numbers on them, the U factor and the solar heat gain coefficient. Think of those two numbers as one being the cold weather insulation value of the window, and the other one may be the warm weather insulation value. It's not really that, but it's close. The solar heat gain coefficient is really just how much of the solar radiation is reflected back out. See, typically you'll want those numbers lower, but there are trade-offs as well. So we look at the side of the house that a window's on, because that obviously makes a big difference if it's on the south side versus the north side here in Utah. The square footage of that window, the efficiencies of that window, and then if it's got overhangs as well, because that's going to dramatically affect how that window is going to perform as well, especially if it's on the south side of the house, where there's going to be big differences in the solar radiation that hits that window summer to winter. And even if it's a really efficient window, having the sun hitting it directly really will affect dramatically how it performs. And windows are the primary driver of air conditioning loads in homes. If you want to have an uncomfortable home, put lots of west-facing glass in there, and even if you've got good views, we actually, I had a conversation with the builder last winter, and it was the builder, and the homeowner. This is a big home up in Summit County, and it still blows my mind that this was the problem. Middle of winter, they couldn't keep the west side of the house cool. They were running their air conditioner in the middle of winter, and it could not keep up with all the west-facing glass in this home. I've never heard of that before. Blows me away. But if you want a really uncomfortable home, put up tons of west-facing glass, and because it's west-facing, eventually the overhangs will not matter. But they were trying to increase the cooling load or increase the cooling capacity for this house just to keep up with it in the wintertime. Crazy stuff. So the window information is very important to the energy model, and in great detail that goes in to the software program. Space heating equipment, type, size, efficiency. There are a lot of ways to heat a house these days. In single family detached, still the standard I think is a gas-fired furnace, but there are a lot more options that are coming to the marketplace now and are being promoted, especially in multifamily. So whether it's a hydronic fan coil or a heat pump or a dual fuel heat pump, there are a lot of ways to go about that. So we need to get that information in there, the size of it, the efficiency, and also the distribution system, how well that is working. Again, whether that's a duct system for a standard furnace, or there are other means for different types of systems. How are we coming on? A few more minutes before our break? Okay. Space cooling equipment. There are a lot of ways to heat homes. I feel like there's really only one way that people are cooling homes, and I just consider heat pumps and air conditioners the same thing when it comes to cooling. But the type, size, efficiency, and I will say this, that cooling systems are a lot more sensitive to correct installation than heating systems. You can have an oversized furnace and it's going to chug along pretty well, and certainly not ideal, but you're not going to feel the effects of an incorrectly installed furnace nearly as much as an incorrectly installed air conditioner. Yeah.
So would you say the same thing when it comes to heat pumps?
Yes, thank you. That is a great point. And heat pumps are really the easiest way of thinking of what a heat pump is. It's an air conditioner that has the ability that's got reverse in it, basically. So the way an air conditioner works is it pulls heat from your house and it captures that heat in the refrigerant and then evacuates it out through your outdoor unit. So if in the summertime your air conditioner is running and you go and you put your hand above it, the air coming out of that thing is warmer than the air outside because it's moving the heat from your house to the outside. Heat pump has a valve in it and the brains to reverse that, so it's able to pull heat from outside and bring it into your house. And the way it's able to pull 40-degree heat from 40-degree air outside and heat your house to 70 inside is more than I would want to get into today, but that's how it works. And refrigeration technology, regardless of which direction you're going, is very sensitive to being sized correctly and they really function far better when you have extended run times. I've talked to a lot of people who have complained to me that their air conditioner is not working right because the thing never turns off. I said, I've got bad news for you. That is a sign that your air conditioner is working beautifully. If your air conditioner is cycling on and off very often, that is the sign that it has not been correctly sized and that you probably don't have appropriate airflow for your system. So, yeah, when people call me up and they've got a fight on their hands and they're ready to go after their HVAC contractor, and you can hear the gears breaking in their head when I tell them they've been thinking exactly backwards. So space cooling, very important that it is sized correctly and that the duct system is sized correctly for the system and for the home, and all that information goes in. Duct system information. So we will put an input into the system, the lineal feet of the ductwork, the location of the ductwork, if it's in unconditioned space, the R value of the insulation on that ductwork, and that really does play a large role in the efficiency of the home. Even even so, code states that ductwork in unconditioned space needs to be insulated to R8. Attics, prescriptive is R49 for this climate zone. So, if you're moving your conditioned air, whether heated or cooled, through an R8 duct, that's there's a lot of energy loss versus R49 is what we're doing to keep the energy inside the home. So there's a pretty big energy penalty for putting your ducts in an attic, and the software will reflect that by letting it know how much of it is in an unconditioned attic, how much of it is in a conditioned space, and all those things. So, should we leave off on duct system? We'll pause the live feed, and we're gonna grab some food, and then we'll start up again at 12:30. Welcome back. We are back for the second half of today's Lunch and Learn. And before we took the break, we were talking about duct systems. Excuse me. But I also wanted to just back up one point and talk about space cooling equipment a little bit more. I had mentioned kind of in passing that I've spoken to actually multiple homeowners who complained to me that their air conditioner always runs, and that was evidence to them that it was not functioning correctly. And so I just wanted to take a minute and kind of explain the way air conditioners are meant to operate, specifically at peak efficiency. So the way that when an air conditioner turns on, it has to, the system has to run for a certain number of minutes for the coolant level or the coolant, not coolant, what's it called? Refrigerant, sorry, there we go. The refrigerant to get cycled through and for the air conditioner to start running properly. And that, and at peak efficiency. And that cycle time is about 10 minutes. So if you have a 13 SEER air conditioner, when it first turns on, it is not operating at 13 SEER. It could be at 2 or 3, and then from 0 to about 10 minutes, the efficiency of that system is ramping up until it is, after that period of right around 10 minutes, it reaches peak efficiency. And if your equipment is sized such that your home reaches its desired temperature after, say, 11 minutes, and your system spends 10 minutes getting up to efficiency, then runs for 1 at peak efficiency, and then turns off, and then X number of minutes later, when the home has heated up enough for the air conditioner to cycle back on, then that's going to start all over again. And so if your air conditioner is cycling on and off, excuse me, then it's spending a significant amount of its time operating below its peak efficiency level. A lot of people like car analogies. Oh, think about the difference of trying to drive from Salt Lake City to Provo on State Street with 150 stoplights versus taking the interstate where you just get up to speed and cruise. It's really the same sort of thing. If your equipment is starting and stopping constantly, it is always operating beneath peak efficiency. And it was mentioned earlier, the HVAC documents that need to be turned into the city. There are three of them, manual J, D, and S. I don't know why they're called manuals, but they are. And the manual J, it's an analysis of the heat loss of the building. And it's in BTUs per hour, British thermal units. And the summary of that document says that this, under certain circumstances, this home will lose or gain, depending on the season, we'll say 80,000 BTUs. And based on that, we will size our equipment appropriately. And part of that equation is the design temperatures. And so what they will say is, so we don't design, the design temperature for Salt Lake City for cooling is, I believe, 94 degrees these days. It's actually gone up a little bit. It was at 92. And what that's designed to be is that is, the temperature is at that level or below 99% of the time, roughly how that works. And so an HVAC system is designed to remove as much heat as the building will absorb under 99% of the circumstances. So what they figure is if the design temperature or the actual outside temperature exceeds the design temperature, theoretically your home wouldn't be able to stay as cool as you want it. And in that case, they say, go to the movies. For those rare occasions. But typically that temperature is around 94 degrees. So what that means is that anytime the outside temperature is, and this is based on the assumption that your HVAC contractor has used all the correct inputs and done his manual J correctly, and use the correct design temperatures, that on any day, at any time, when the outside temperature is at design temp or greater, your air conditioner should be running constantly. Once you drop below that, if you've got a single speed air conditioner and it's 80 degrees outside, yeah, it's going to be cycling on and off because you're quite a bit below that design temp. But in a correctly sized design system, if you're at that design temp or higher, your system's running constantly. And typically, a furnace is going to be sized larger than an air conditioner. So you might have an 80,000 BTU furnace and a 60,000 BTU or 5-ton air conditioner, and that's because it gets colder here in the winter than it gets warm in the summer. So you need to have more BTUs to keep the home at a constant temperature. But again, that's kind of the theory behind why an air conditioner running all the time is not necessarily a bad thing. Certainly there could be a problem with the thermostat where it's not functioning correctly. But yeah, don't be afraid of an air conditioner running constantly on a hot day in July. Be more afraid of your air conditioner cycling on and off on a 95-degree day in July. That is a red flag that your system has been significantly oversized. Also note that oversizing systems significantly reduces their life. A gentleman I know who's an HVAC contractor, I think among the smartest in the state, he put the furnace in my house. He said, I don't know what it is about the magic number of 8, but oversized HVAC systems seem to die at 8 years in service. He said, it's weird that it happens disproportionately that long after. And I asked him, what about a properly sized one? 30, 40 years ago, almost forever if they're correctly sized. So it's the same thing, highway miles versus city miles. So that's a little bit about cooling. Yeah, so if you're in this world of building, and people always want the biggest and best, and they say, well, just put in the biggest air conditioner you can, know that that is oftentimes a really big disservice to the homeowner. So, and one of the big problems as well, as we head back down to the duct system, if you put in a oversized or even correctly sized furnace and AC combo, if your duct system is undersized, it doesn't matter. It won't allow your HVAC system or your furnace AC combo to function correctly. It just won't move the amount of air. Air conditioners in particular need to move a lot of air for them to function properly. At this altitude, it's right around, and some people will disagree, but 400 cubic feet per minute per ton of cooling. So if you got a 3-ton air conditioner, you should be able to move 1,200 cubic feet of air through that duct system, and not just theoretically, actually, or it just won't work. So, appliance information. This is a lot more simple. All the appliances that go into a home, that information is put into the software. Certain appliances are a lot more important than others. Certain things, there's just not that big a difference between the best and the worst. I think about like an electric range top. They're all pretty much 100% efficient. There's not one heating element that's much better than any other heating element. Other things like refrigerators, there can be significant differences between the efficiency of the different refrigerators, as well as the size of the refrigerator, of course, is going to help determine how much electricity is going to be consumed by that. So these are additional items that go into creating an accurate model that's going to help for a lot of reasons. Lighting information. Probably the biggest change I've seen in anything in the past 10 or 15 years is lighting technology. And if you're a kind of an efficiency dork, like I guess I am, it's really exciting. I was looking at the lights in here, and they scream of 2008. They're these old pin-based compact fluorescents, harken back to the old days of I'll just say substandard light. Current lighting is fantastic. I think it's exciting. There's so many opportunities. You can adjust the color of it, and there's a lot more ability to use unique and interesting lighting in your homes. The software accounts for the type of lighting and the efficiency of lighting, and again, there's really no other technology has increased in efficiency as much as lighting in the last decade. It's remarkable that what used to take 100 watts of power to create 1,600 lumens now is happening with 16 watts of power. So it's a huge drop. I mean, furnaces have gone from 90s to 95. That's a 5% increase. That's great. But nothing can touch the efficiency gains of lighting. So, and again, that is part of the equation. Home ventilation information. So we look at not just whether or not the home has a ventilation fan in the bathroom. That's required by code, and that it's not binary by any means. It's pretty easy to install. I don't know what a builder grade entry-level fan costs, $20, $40, something like that. They don't move a lot of air, to be quite frank. And some of the things that we look at are not just the specifications of the fan, how many CFM it's advertised to use, but also how many watts of power it takes to move that air. And then in a post-construction situation, we also measure the flow of air to make sure that the advertised rate, that we're getting at least close to that with the actual rate. So, and there are flow hoods that are used to do that. So that again, it's important that we're removing moisture from homes. Going back to some of the training that HERS raters receive in building science, and that is studying the flow of heat, air, and moisture. And what we're taught is that heat and moisture will always travel from more to less. And if through poor ventilation you're building up additional water, moisture in your bathroom, it is creating additional pressure between that level of moisture and the worst case is the outside, especially in the wintertime where the humidity is very, very low. And that will, that moisture is always trying to find equilibrium. Nature loves equilibrium. And you've got warm, humid air on one side of a wall and cold, dry air on the other. The warm, humid is trying to get to it. And the greater the difference between the two, the harder it's pushing. So if you've got a non-functional ventilation fan, and let's say theoretically a teenager who likes long, hot showers, I have a tankless hot water heater in my house, and one day my daughter went home early from school because she wasn't feeling well. And when I got home from work hours later, I asked her, I said, so tell me what you did today. She's like, I showered. Tell me what else you did today. I just showered. She had a nightmare going through my head. I'm like, the hot water never runs out at my house. I bet she was in the shower for 4 straight hours. So tankless hot water heaters can be a double-edged sword. But I think about the amount of moisture that would have gone into my bathroom during those 4 hours of my daughter's shower. And you need to have an effective fan to remove those. Again, or you've got physics working against you if you've got all that moisture in your house. Air infiltration information. So, and what that is a blower door test, and it's really how much air leaks into your house at a given pressure. That pressure is 50 pascals. A pascal is about 1/250th of an inch of water column. Do you happen to know what it is? PSI. It's like
No, it's like a sticky note falling.
it's a sticky note falling. Some people call it like a gnat's fart. It's really 1 pascal is a very small amount of pressure. Yeah, so a 1/5 of an inch of water column is what 50 pascals is roughly. And that is the pressure that we'll take a home to in seeing how much air leaks in or out of it. And typically we will put the home under negative pressure. And so we're seeing how much air leaks into it. We're not blowing it up like a balloon and see how much comes out of it. Sometimes, but usually not. I assume you do negative pressure most of the time? Yeah. And what that tells us, well, how well the home has been air sealed, if there are any gaping holes. Usually, quite honestly, there aren't gaping holes in homes. What I've found, and much to the chagrin of our customers, is that most of the time it's death by 10,000 pinholes. Homes will leak a tiny bit in thousands of different places, and it can all add up to be quite a bit. The energy code in the state of Utah accounts for this. code states that homes are allowed to leak. Single-family homes, no more than 3.5 air changes per hour. So an air change per hour is the volume of the home in cubic feet. And so, yeah, the volume of the house, that amount of air is allowed to leak out 3.5 times every hour. Sounds like a lot. Homes actually do breathe a lot more than people think, even modern homes. And that is handled with, I've got a slide here that shows a blower door test being done. Anyone here? Obviously, I know we have a HERS rater in the room who's obviously not just seen a blower door test, but done lots of them. Everyone's seen blower door tests done? Okay, no. I'm not sure exactly where they're. Duct leakage information, and I'll show a slide of a duct leakage test as well. Similar concept to the blower door, but instead of testing the integrity of the entire home itself, it is just the duct system. And I showed the slide earlier of the deplorable butterfly joint. Duct leakage information is, or tight ducts, it's required by code if the ducts are outside of conditioned space. But it's also required to have a tight duct system really for the proper function of the HVAC system. During tests, when the HVAC contractor's on site and their duct system is not functioning so well, they've tried to make arguments of, well, if it's all in conditioned space, who really cares? Because it's just leaking inside the house. And I think, well, maybe this isn't good logic, but by that same thinking, why even put a duct system in if we don't care if it leaks? I think the principle here is calculating correct function and controlling air movement in the house, because HVAC systems that have leaky ducts, leaky returns, can create driving forces that can move air and moisture where you don't want it. Remembering that the return side of a HVAC system is negative pressure. It's a vacuum, it's sucking. And so if there's a hole on the return side, it is sucking air from the space that it's in. And, what if that is in some interstitial space and it's finding a hole that is pulling air maybe from your garage, and you store gasoline in your garage or other volatile organic compounds. There's a lot of opportunity for unintended consequences. And so I think it's really important, not just for the function of the HVAC system, but for the safety of the house, and just to make sure that everything is working as intended. Because again, if your HVAC contractor is doing a correct manual J, D, and S, and it's all based on correct information, then the idea is that system is in control of the function of the house, the comfort of the house. So, and then your ventilation system is also working to make sure the house is functioning as it should. Any questions? Okay, we'll move on. Renewable information. So it's probably last on this slide, as it should be. As I mentioned earlier, there is a crossover point in the efficiency of a home where it makes sense to put renewables on your house. And that crossover point is the Department of Energy has really tried to capture that in their Zero Energy Ready Home program. Years ago, I worked on a pilot solar incentive program for Rocky Mountain Power. And my job was to make sure that if someone, once they had applied for incentives, that they didn't already have panels on their house, because that was part of the program. We didn't want to pay you for panels that you already installed. So make sure there weren't any when you applied, and then make sure you did install them when you said you did. So, and at the time, solar cost about $11 a watt installed. It's a lot less than that now, but back then it was about $11. And as I was inspecting these homes, I would see halogen and incandescent lights, and I would just do the math in my head. If you've got a 100-watt light bulb, how much solar does it take to run that? 100 watts times $11 a watt, over $1,000 worth of solar to run a 100-watt light bulb. How much does it cost to take that 100-watt light bulb and replace it with a more efficient 20-watt light bulb? A lot less than $800. So, and I would have this discussion with people. You know what? You'd be better off replacing your 7-SEER air conditioner and installing a 13-SEER and lowering your load by X number of watts, rather than just throwing a ton of solar at a really inefficient home. And I think part of the allure of having cool solar over road, it's just a lot more fun to put solar panels on your roof than it is to put a new air conditioner in your backyard, I suppose. But my point in saying this is renewables are fantastic under the right circumstances, and they're never the first thing you do. They're always the last thing that you do after you've upgraded everything else. And again, if your house isn't at HERS 40s or 50s, you're probably not spending money as wisely as you could by putting renewables on. Again, last thing that you do. I think they're great, but you can't get blinded by the fun of putting solar panels on your house until you've put good lighting, insulation, equipment, all those things. Water heater and water distribution information. So we like to know, or the software likes to know, if it's a storage or if it's on demand. If it's storage, how many gallons, what the efficiency rating of that is. The distribution system, does it have a circulation loop? Are the lines insulated? Really trying to encapsulate all the information that would determine how efficiently your domestic hot water system is working. And if you've got teenage daughters that take 4-hour showers. So, okay. So here's a photograph of one of our old employees doing a duct leakage test, duct blaster test. It's called duct blaster because the equipment manufacturer, that's what they call their equipment, is a duct blaster. So nothing gets blasted. That's just what they call it. So what we have is a small fan, and it's a calibrated fan. It knows how fast it's turning, and it knows how much air is passing through it. There are different rings you can put on there to change its accuracy. If you've got a system that leaks very, very little, you'll put a ring on it that necks it down and allows it to be more accurate. And then what he's got in this, and I'm sure we just did it for the photo, the little gray box in front of it is a theatrical smoke machine. And those really only get used when we are either doing a presentation or you've got a leaky duct system and we're trying to, oftentimes it's trying to just prove to HVAC contractors that their systems actually do in fact leak. You blow smoke into it, they get to see it ooze out through all of their joints, and then they actually believe that their systems leak. We have a small computer slash pressure meter called a manometer, and that is all the brains behind it and tells you how much it's leaking. The formula for this, according to Utah code, is 6 CFM per 100 square feet of floor space that the system is servicing. And by code, you have to meet this if 20% or more of the duct system is in unconditioned space. It seems to me like most systems are like mostly all in or all out, aren't they? You don't get a lot of them that are half in or half out. Most of the time it's, I don't know, at least from what we see. We work with a lot of production builders, and it seems like if it's a 2-story home, they put an attic system in, and most of that system is in unconditioned, and so it needs to be tested. So 6 CFM per 100 square feet is what code allows. So, state energy code. Here's something to note. Sometimes builders will say, well, I'm in X city, and so we don't have to do that there. Like, okay. So, some smiles in the audience today. There is no city or county building code in the state of Utah. It is a state building code. It is determined in the state of Utah. It's a legislative process. That's why I mentioned earlier that next year's residential energy code would be determined during the legislative session. So the state determines what the energy code is. It's the county or the municipality that enforces that state code. And just to be frank, I will say that it is unevenly enforced throughout the state. There are some municipalities that are quite serious about it and are sticklers, and there are others that are less strict about it. There's a builder that I work with, and they were starting a new project in a city that they had not built in previously. And he said, I talked to my code inspector, and they don't require air blower door testing. So what do I do? He's like, should I air seal at all? And if so, like, to what level? He was just a little lost because the city had just flat out told him, at permit time, we are not going to do any testing on this. And so he asked me, why should I air seal this building, and how tightly should I do it, because the city doesn't care. And I said, well, if the city doesn't care, how about this? Why don't you air seal with occupant comfort and building durability in mind? Let those be your guiding principles for air sealing this building. You're gonna own this building for a while, so hopefully you care about its durability, and you don't want to, when you come to sell it in 5 years, you don't want the buyer to find mold or rot in the walls because it wasn't air sealed. And also you don't want people complaining about really high energy bills because the units are so leaky. So with that in mind, he said, yeah, that sounds pretty reasonable. We'll do that. So in absence of the city caring, that's what we did. Note that whether the city requires energy code testing or energy code compliance or not to give you your C of O or pass your final inspection, you are still legally obligated to follow all of the state code. Just because someone gave you a C of O doesn't mean you are no longer responsible to have passed that code. I know that there are law firms operating in the state of Utah and whose business model is construction defects. So I think if in a court of law, if that if it was able to be shown that you didn't comply with state energy code or state code of any type, that would be make it difficult to win your case. So just know, even though you got your C of O, you're still exposing yourself to liability. Okay, so the duct leakage is part of the energy model. It really is quite important, especially if your ducts are in unconditioned space, that they be tight, because that you're leaking conditioned air into unconditioned space. Most of our attics in Utah are vented, and so they're pretty typically, at least in the winter time, they're pretty close to the outside temperature. Summertime, in the afternoons, they're 20, 30 degrees higher, which is actually even worse if you've got a 135-degree attic and you're leaking 55-degree conditioned air into it. It's a huge energy penalty, and at that point, you might have 40% of your energy being wasted going in the attic with low R values and leakage. So, big energy penalty. It's also a requirement for green programs. Energy Star has a pass-fail level that actually is the same as our state code right now, 6 CFM per 100 square feet. We kind of just call it 6% for some weird reason. It's not percent, but that's the industry shorthand for it. 6% duct leakage for Energy Star. And again, a lot of other green programs use Energy Star kind of as a foundation. So, as I mentioned earlier, trigger for code-required testing is 20% of the ducts in unconditioned space, or if you have the air handler in unconditioned space, that's an audit, regardless of the ductwork, that triggers a duct test requirement. As I mentioned, 6 CFM. So this is a blower door. It really is, in principle, the same thing as the duct test. The fan is just a lot bigger. Do you recall how many CFM a duct blaster will move?
A lot.
A lot. Couple.
500.
500. So
I've never seen 500, but
yeah, this will move 6,000, I think. 6,000 CFM. It's much bigger. It needs to be, because the home is tested at 50 pascals, the ducts at 25 pascals, double the pressure, and of course the space is a lot larger. So, and again, you can see that we've got an aluminum frame. You can't see that it's aluminum, but it is, and then an airtight fabric door that the fan fits into, that allows us to depressurize the home. So, as I had mentioned, 3.5 air changes per hour is the threshold for air leakage in the state. Note also that once you hit 3 air changes per hour, mechanical ventilation is required in the home. So there is a tight window where you're tight enough to pass code, but not so tight that you need specific mechanical ventilation for it. And some of the materials, we were supposed to drop to 3 air changes per hour, but that was changed a year or so ago. Note that with multifamily, it is 5 air changes per hour, a little higher. I will say that I think it's a lot more difficult for multifamily units to hit 5 than it is for single family units to hit 3.5. They're just inherently far more difficult to air seal. And do you find that to be true?
very much so.
Very much so, yeah. A big home on a basement might pass 85% of the time without any heroic measures, but I've never seen multifamily pass 5 air changes per hour without really deliberate air sealing happening. You just never pass by accident. It's a lot more challenging. This is a component of the energy model. You can't really decide how energy efficient a home is without knowing how much air it leaks in and out. I don't even know that our equipment would go up to this, but I know a gentleman who does air sealing, and he was working on units that were leaking 22 air changes per hour. Yeah, I probably have to put 2 fans in the door to get enough pressure to do that. If you're leaking 22 air changes per hour, you've got serious problems, and I would be afraid for the comfort and of the occupants and the durability of the home at that point. Blower door testing is also required for above code programs. Energy Star requires it. Others as well, but again, typically Energy Star is a foundation for a lot of other programs. There is a component in the code that allows you to not have to blower door test. It is the air sealing checklist. I didn't put it in the slide deck. It is up on utahenergycode.com. I did a series of classes for the Home Builders Association in 2021, and I always like to take informal surveys. And I asked how many of you actually filled out the air sealing checklist and handed that to a code official as a method for passing the energy code. And no one ever did. You know, class after class, not a single person had ever even heard about it. And then one guy finally raised his hand. Yeah, I do that. I said, where did it happen? Well, in Idaho. Okay, so before the year was out, I did find one guy who had actually turned in the air sealing checklist. I will say this, that if you are honest and deliberate about filling out the air sealing checklist that's in the code, it'll be far easier and less costly for you just to blower door test your house. The air sealing checklist is quite comprehensive, and if you do it as intended, you would certainly get a great result on your blower door test, but it's certainly not a loophole to get it out. It'd be a lot more difficult. Okay, so I've mentioned in here a lot about how going the ERI path really kind of gets you started down the road of above code programs and certifications. And I'll just say this right now. I'll save it to almost the end. If your interest is building an absolute code minimum home with regards to energy efficiency, I don't think the ERI path is the way to go. I really don't. I think one of the res check paths is the way to go. If you are trying to build the legally least efficient home that the state of Utah will let you, don't go the ERI path. If you are interested in understanding the performance of your home and optimizing the performance of your home, then the ERI path has a lot of opportunities for you to understand those things. And some of those things that the ERI path really gets you started on are green programs. I don't like the word green, but people understand what I mean, and so we'll just go with it. There are HUD financing programs, low-income financing programs that require certification to above code programs. Some of them, they don't really care which program. They just state your home needs to score a level of efficiency at a certain level, and then you need to choose an above code program and certify to it. The Olene Walker Housing Fund is one of the methods that people use to do that, and that does require certification to a program. So going the ERI path gets you headed down that road. Federal tax credits, we'll be doing a class later on that focuses on the 45L. That's kind of designed to be a more single family type tax credit. The 179D is more of a commercial building tax credit. But again, same principle, going the ERI path really gets you headed down the path of understanding the efficiency of your building and knowing where you stand in relation to the opportunities that are available for building structures that are above code minimum. So you've heard me say Energy Star a lot of times. That is one of the programs that probably the ERI or the HERS score is a requirement for Energy Star. It represents the efficiency level that you need to hit in Energy Star. Enterprise Green, that is typically more for multifamily structures, and it takes a lot of other things into consideration, but Energy Star is one of the paths to compliance in that as well. So again, ERI gets you headed down that road. LEED, less so with LEED, but again, understanding where the building's at and where your shortcomings might be in relation to getting that certification. Zero Energy Ready, that is also something that is a trigger for the 45L tax credit. Again, it's more demanding than Energy Star, and it really does, I think it gets your house, I'll say optimized for energy efficiency. It really does try to stop right where going beyond that level of efficiency starts to get really expensive. And that's a DOE program. NGBS Green, there is one community in Summit County that requires that to build. Again, Energy Star components go into that as well. Utility rebate programs. So Rocky Mountain Power and Dominion Energy both offer incentives for building new construction that is more efficient than code. And both of those programs are performance-based in different ways, but we're able to take the information from an energy model and use that to apply for the incentives on behalf of the builder. So going the ERI path gets you started down that road, and some of that work's already done. So the end goal, and what I think ERI path really helps you do, is HERS scores are really a great way to measure and understand where you're headed if you are really trying to build the most efficient homes that you can, that are a great value for everyone. Testing gets you code compliance. It provides inputs for modeling, and the modeling allows for the green programs and the rebate programs. And then all of those programs lead into financial benefits, whether they be utility incentive programs, federal tax programs, multifamily financing programs. So there are a lot of opportunities that you can leverage when you build above code. So how to work with an energy professional. As mentioned, the list of HERS raters in the state is up on utahenergy.com. It's com, isn't it? I'm pretty sure it is, yeah. utahenergycode.com lists the HERS raters. And optimally, consult in design phase, provide project plans for analysis, and then provide scheduling software, or at least let the HERS rater know when they need to be on site to do their inspections and testing. So that they, because inspections and testing has to happen during the process. It can't just be called the final. And then documentation will be requested for certain things. Certainly the utility programs have documentation that needs to come from the builder. And so the energy professional, the HERS rater, will just get those. And then I shouldn't say this, but we do paperwork for our builders. I won't say that everyone does. I don't know most that I know. I know most of the HERS raters in the state, and most will do the paperwork for you. So, questions? I did a lot of talking.
I wanted to ask you about registers and covering registers to maybe save energy in a room. Is that a benefit? Like I got some rooms in my house, I don't necessarily want heat in the winter. Covering the register is a bad idea in that room. Does it affect the HVAC system as a whole?
Absolutely, it affects your HVAC system. Do I need to repeat the question? So the question is it a good idea to cover registers to save energy? If you've got a room in your house that isn't being used and you want to cover that register up so that you're not heating it needlessly throughout the winter, be careful. You gave the example of wintertime. I would say it's a lot safer to do that in the wintertime than it is the summer. But there are potential downsides to doing it even in the winter. And what that is airflow problems. So if you've got a single speed furnace, and let's say it is an 80,000 BTU furnace, you've got the burner that is creating that amount of heat, and then it's got a fan that is moving that heat out of the furnace cabinet throughout your house. Maybe covering one register won't be a big deal, but if you end up doing more, what you're doing is you're lowering that airflow, and so that is going to raise the temperature inside your furnace beyond what it's specified for, because it's designed to have a certain amount of airflow through it. And if you're plugging up registers, then that temperature is going to go up. Now, on the flip side, in the summertime, I would not cover registers in the summer when you're cooling, because I mentioned earlier that you want to have, in a perfect world, 400 CFM per ton of cooling going across your AC coil to remove, to carry that heat. Let's see, what are we doing? We're actually removing the heat and into your coil. And if you don't have enough airflow, bad things happen. So anyone had their coil ice up? Yeah. We had it ice up at our office a year or two ago, and once we realized the AC wasn't working, go into the mechanical closet and see water dripping out of the coil. And we're like, okay, so we know what happened. We go around to all the registers, and a lot of the people in the office didn't like having the cold air blowing on their bare arms during the day. And we had like 7 or 8 registers in the office, and 5 of them had been blocked off. And so we just weren't getting enough air flowing across the coil. And what happens is there's humidity in the air, and at room temperature, it's just vapor. But when it goes across that coil, the surface temperature of the coil is cold enough that it condenses into water, and that's fine. Air conditioners remove moisture from the air. But if there is so little air moving across the coil that the temperature of that coil drops below freezing, then rather than the humidity hitting it, condensing into water and dripping into your drain, it condenses into water and then freezes, and then then it just turns into a huge ice block. That's the most extreme example, and it's not necessarily a big deal. You just turn the AC off for 6 hours or something like that, and it melts. But it just doesn't function the way it should. So I would not block off registers in the summertime unless a trained HVAC professional told me that the system could handle it. And in the wintertime, I would just be careful about overheating your furnace. So, any other questions? Yeah.
So, I'm in a house down south in Mapleton that's close. Huh? What, the mic?
Yeah, let's get the mic.
Where it gets very cold because it's a very old house. It's from 1890 something, and my in-laws and my wife are from Panama, where we just moved back recently. I've never lived here in Utah up until a couple months ago. I'm from Southern California. So we're all used to warm, though theirs is warm humidity. It's very hot and tropical down there. And so here they're struggling with the cold weather and want to have the heater on all the time. And, I get hot relatively easily. I don't want it to be.
Is this a marriage question?
No. So my question more is is there like an optimal temperature that you should set your furnace at? I know that's a father struggle that people always, they want to turn the furnace off, or they don't want it to be hotter than normal because of energy costs and things. But is there like a more correct temperature to set it at to keep it? Mine doesn't turn off and on like you were saying. It's a constant running.
Yeah.
But I just don't know if my furnace is set too high just because my family's struggling with how cold it is.
What's it set at?
It's about like 75, 76. And of course I'm sweating and I turn it off in my room, but it gets hot for me.
So there are, this is funny, there's ASHRAE. You guys know what ASHRAE is? It's the American Society of Heating Refrigeration Engineers, I think, something like that. They actually have published comfort standards. So if you really are looking for some reference to leverage your comfort in the home, which it sounds like you are, I would go with ASHRAE. Now, of course, that comfort level, it's not going to be just a temperature thing. It's always going to be temperature and relative humidity, because of course the humidity is going to greatly affect the comfort level. One thing you may not, there is something called the mean radiant temperature. You familiar with that? Really what affects our comfort isn't nearly as much the temperature of the air that might be blowing in the room, but it's actually the surface temperatures of the walls and the windows in the room. And if you notice that you're standing by a window in wintertime, you might feel like there is, in fact, people think that windows are leaky all the time when they're not, because they go stand by them, they get really cold, and they think it's leaking, but what it really is it's a convective loop that's operating on the surface of that window. But just standing next to that cold surface, again, nature wants equilibrium. And if the surface of your skin is, upper 70s, I think, and the surface of that window is 40, if you've got a 30-degree delta, and it's radiation, so you don't have to be right next to it to happen. The surface temperatures in the rooms in your house will greatly dictate the comfort of the occupants. That doesn't help you at all with your problem, though.
No, but I'll look up the ASHRAE.
Look up the ASHRAE standard. That might help you. But know that controlling surface temperatures in your house is what really dictates the comfort of the occupants.
I think the EPA says 68 degrees is like optimal.
Yeah, that would be perfect for me. It's just too hot.
Sweaters.
I love being in a cold house wearing a sweater or a blanket or something, but they're used to 85, 90 degrees, tropical humidity all day long, every day. It doesn't fluctuate more than about 15 degrees between day and night all year round. So,
Oh, well,
I lived there for 10 years, so I was used to the heat as well, but
yeah, well,
I prefer cold.
best of luck. I would go with the ASHRAE standard. Yeah.
The other factor is teenagers.
Teenagers are a factor. Yeah, I was telling someone at the break that my son, who's 20, has a ridiculous metabolism, and he moved his bed right next to the window in his room and then left his window open all winter long because he likes it 50 degrees, so kids. All right. Thank you so much for your participation, and hope to see y'all again soon.